First things first, many would argue that the term expanding is misleading. The stars and galaxies do appear to be rushing away from one another for sure, but it might be more accurate to say the space between them is stretching, rather than the universe expanding like a balloon. Anyway, what is it expanding into? The answer is, it depends. If the universe is infinite, then the question is nonsense. Something that goes on forever can't have an edge or anything outside of it. If the universe is finite, then the question is more interesting. The thing is about physicists is that they have a habit of talking about the universe in terms of four-dimensional space-time, although the simple answer is really, we don't know. Theologians who have pondered this question have tended towards the God-created time, so there was no before tact. Remarkably, many modern physicists would also tend to agree, but for slightly different reasons. And again, we have at least two options. If time began at the Big Bang, then, like the question of what the universe is expanding into, the question is nonsense. In relativity, time is said to stop as you approach singularity. So if the universe was at the point of singularity at the Big Bang, then time would have been at a total standstill too. Some physicists, however, don't like this explanation. Many physicists, in fact, don't even like the idea of singularities, as they're really only representative of the theoretical point at which our mathematics falls apart, as opposed to real things. In fact, there are quantum interpretations of the history of the universe that don't include a Big Bang at all. There are other theories that suggest that our universe was born inside a black hole in another universe, and that the black holes in our universe are, in turn, belching out their own universes. And some observations of the cosmic microwave background, CMB, appear to show the shock waves from the collision of supermassive black holes before the Big Bang. The truth is, though, that we just don't know. Sometimes when you look around our planet, it seems inconceivable that there couldn't be more like it out there. However, given the sheer scale of not only space but time too, the chances of coming across any little green men suddenly appear to be vanishingly small. Little green men aside, the estimates for the likelihood of finding any kind of life at all in the universe range from 99.999% certainty to less than 1%. And it all hinges on finding just one single, solitary bacteria somewhere other than Earth. If we were to find that life has sparked itself into existence on, say, Europa, it would immediately double the number of known inhabited places in the universe. For life to arise once could still be chance, but for it to arise twice on two different celestial bodies, although Europa is a moon, but whatever, drastically increases the probability that life is common as opposed to rare. If we establish that life is common, it then becomes much more likely, perhaps even inevitable, that intelligence would emerge. All this said, even if the aliens are out there, contacting them is a whole other kettle of fish. When scientists tried to tot up the sum total of all the matter and the energy in the universe, they found that they were coming up significantly short. Dark energy makes up the largest part of this mysterious hidden universe, with scientists estimating that it accounts for around 74% of the energy density of the universe. It is essentially an invisible force, a kind of anti-gravity that pushes and pulls everything apart. The other side of the coin, dark matter, is thought to make up 22% of the matter in the universe. The only problem is that it doesn't interact with the electromagnetic spectrum, and we have no way of detecting it. We can only infer its presence from its effect on the rest of the universe that we can see, namely the gravitational lensing caused by the warping of space-time. To be clear, you need to get the image of an inky kind of matter spread out across the universe out of your head. There is nothing necessarily dark about dark matter. It's just a placeholder name because we don't have the foggiest gist of any of its qualities. Plus the whole not interacting with light thing, I guess. What are numbers? You probably don't go more than an hour at a time without using numbers in some form. But when you think about it, how would you explain them to, say, an alien that has no concept of what they are? Numbers are points, squiggly lines, factors. But are they real things, or are they simply the best method we have for describing the universe around us? While we're on the subject, There are many who think it's pretty weird that numbers appear to work so well. So far, the vast majority of reality has proved itself to be computable. We can summarize some of the most complex interactions in the universe by writing down a few numbers in the right order. While it's tempting to say that numbers are simply human constructs, there is a good argument to be made that there is something fundamentally quantifiable about the universe, and our numerical representation of that could just be allowing us to glimpse it. There are also those who view the amazing nature of numbers, not as a happy accident or evidence of man's genius, but as highly suspicious, almost as though someone planned it that way. There are those, including Tesla CEO Elon Musk, who think that it's a virtual certainty that our universe is actually being simulated by someone else. Their reasoning is this. In the past 20 years or so of the computer age, we have made such massive strides in the fields of simulated and virtual reality that it stands to reason that it would be possible for any sufficiently advanced species to create a perfect simulated universe. Imagine a self-aware computer program capable of simulating its own universe in a kind of technological equivalent of Russian dolls. If we accept that this is possible, then the chances of us being the very first civilization, the real one, are extremely slim. It's actually much more likely that we are part of the however many other subsequent simulations that have been created from the first. So, is there any evidence for this? Some researchers believe it could be possible to detect the underlying grid structure of the simulation by studying high-powered cosmic waves. Others think that the very fact that the laws of physics are so computable, as discussed in the last entry, is an indication that reality could have been programmed to abide by simple rules. On the flip side, it's possible that this is all a misplaced anthropocentric existential angst. Why is there something rather than nothing? We tend to take our existence for granted, because we spend most of it doing things like catching buses and scrolling through Twitter. But the very presence of, not only us but the universe in general, is reliant on a very specific set of physical laws coming together. The thing is, there's absolutely nothing about physics that suggests it has to be this way. It's, as far as we know, an incredibly unlikely accident. We don't know, for example, why there appears to be way more matter than antimatter. The two are created in the same events, and should, by all rights, annihilate one another immediately. And yet here we are, surrounded by a universe made of matter. Had one of the fundamental laws been tuned slightly differently, the universe would never have come into being. Matter would have disintegrated, or never formed in the first place. Obviously, you could argue that, had the universe turned out that way, there would be no one there to observe it. We are only able to question the bizarre serendipity of our situation, by virtue of that serendipity. Even then, it doesn't make it any less unlikely. And unlikely is generally not a scientist's favorite word. There may well be an underlying reason as to why a universe should form at all, but for now, we'll just have to be thankful that it did. In conclusion, the universe is filled with unanswered mysteries that continue to intrigue and inspire us. From the origins of the cosmos to the possibility of extraterrestrial life, these questions drive our quest for knowledge and understanding.